Hello everyone. Welcome back to our channel, and in today's live streaming we are going to be talking about digital electronics, and we are specifically going to study the digital logic families in detail for our UPSC Engineering Services examination. This would also help the students who are preparing for the GATE exam, and also for the students who are preparing for digital electronics during their graduation or semester exams. Right? So let's dive into it. So very first we are going to see a simple understanding of how these logic families represent different kinds of digital circuits for logic expressions. Right? So there are these different integration levels. That means these are the different integration levels, and using these different integration levels the number of gates or number of chips used inside changes. Right? So very first one is the small scale, then we have the medium scale, large scale, very large scale integration, and ultra large scale integration. So respectively they have these number of gates or chips that are being used. So in the exam they might ask you uh, what is the difference between large scale integration and very large scale integration. Then one difference is the number of gates and chips that are used inside. Right? So very first let's look at the classification of a logic family. So basically the we can say that the set of compatible ICs with the same logic and the same supply of voltages have been fabricated to perform the various logic functions, also known as the logic family. Right? Now these logic families are divided into two. One is the bipolar and one is the unipolar logic family. Right? So under the bipolar logic family we have these different two types. First one is saturated one, and the second one is non-saturated one. Right? Under the saturated specifically we have the resistor transistor logic, DCTL, that is direct coupled transistor logic. Then we have integrated injection logic, diode transistor logic, high threshold logic, and transistor logic. We are going to be studying about these a few of these in detail. Okay, then we in the non-saturated bipolar logic family we have two types. One is a Schottky TTL. TTL means transistor logic, and ECL, that is emitter coupled logic. Right? Under the unipolar family we have three types: PMOS, NMOS, and CMOS. Right? So now let's dive into the different characteristics of digital ICs before understanding the different logic families. Right? So the very first characteristic is fan in and fan out characteristic. Right? So now basically what is fan out? So it is nothing but the capability. I'm talking about the capability of a logic circuit to drive maximum number of similar gates. Right? So basically it is capability to drive maximum number of similar gates. Right? So in this case at the output you can see there are four gates over here. So the value of fan out is nothing but equal to 4. Right? So if I consider the same circuit I can say that fan out is nothing but 4 in this case. Right? Now let me show you. Let's consider the same circuit. One second, I'll just change the in color. Okay, look at this diagram in here. Okay, this diagram I'm talking about fan out. Okay, in the fan out condition, see this output over here is nothing but I O H. Right? And this output input given over here is nothing but I H. Right? So in this case IOH is nothing but high level output current over here. This is IOH is nothing but high level output current, and over here IIH is nothing but high level input current. Right? So we can say fan out fan out is nothing but minimum of minimum of IOH upon IIH, comma, that means it is nothing but IOL upon IIL. So that is nothing but, we can say fan out is nothing but minimum of high level output current divided by high level input current, and high level input current divided by low level input current, right? So basically the maximum number of digital inputs that the output of a single logic gate can feed, and the gate must be of the same family. So fan out over here, the definition is written. Fan out is calculated from the amount of current available in the output gate and the amount of current needed in each output of connecting gate. So this formula over here means the same, right? So exceeding the specified maximum load may cause malfunction, because the circuit will not be able to supply the demanded power, because the manufacturer already has specified the value of fan out in the data sheet, right? So this is nothing but fan out. Now what would fan in be? Fan in or gate is number of inputs that can be practically be supported without degrading practically input voltage level. So what is this? Fan in, right? Fan in, right? Now let's move on to the next characteristic of a digital IC, that is nothing but noise margin. Noise margin, or we can say noise immunity. So what is noise? Noise is present in all real system. This adds to random fluctuations in the voltage representing the logic levels. Hence, the voltage ranges defining the logic levels are more tightly constrained at the output of gate than the input. So, noise margin in logic state 1, over here you can see, is given by VNH. VNH in logic state 1. So, VNH is nothing but equal to high level output voltage VOH minus high level input voltage, right? So noise margin in logic 1 is nothing but VNH, and noise margin in logic 0, that is nothing but VNL, is equal to, what would it be? Yes, it would be low level input voltage minus high level input voltage. Low level input voltage minus low level output voltage, right? So this is nothing but the formula of VNH and VNL, that is nothing but noise margin in logic 1 state and noise margin in logic 2 state. So the maximum noise voltage that can be tolerated by a circuit in terms of noise immunity is nothing but called as noise margin. So you need to remember the formulas over here, right? Now next is propagation delay, right? Next one is propagation delay. So what does it basically mean? Is it's a measure of how long it takes for a gate to change its state. So say initially it is 0, but how long will it take to convert the state into 1? So how much time does it take for a gate to change its state? Yes, and the propagation delay should be as low as possible, right? So ideally it should be as short as possible, and the propagation delay is nothing but, the formula given over here is uh, TPHL plus TPLH, that means high level and low level, divided by 2. So this is the average time propagation delay which is given by TP, right? Now let's move and see, look at the basic characteristics. So you can see over here the basic characteristics or ICs. First one is propagation delay, then we have power dissipation. Power dissipation is nothing but it is wastage of power across the circuit components and devices during its operation. right? So it should also be, power dissipation should also be as low as possible, right? And it is generally expressed in milliwatts. Okay. Now next is fan in and fan out, that we've already seen. We have seen about the noise immunity as well. Then there are some power supply requirements that should be matched, right? That should be matched. Then the next one is